Thank you and welcome to my talk today. Yes, thank you Marcel for the short introduction. I will specify a little bit of the introduction. I'm from Continental, that's correct. And especially I'm from Continental Tires. So we are not only delivering the very best tires that you can have on your car, we are also delivering many cars for car systems, like for chassis, for the motor, for all you can imagine, all the sensor systems and stuff. But I'm from Tires, and 10 years I worked as a freelancer, as a data scientist. 10 years before I was known as statistician. So, and a year before I decided, or I was asked by Continental if I want to bring this knowledge into the company, and I decided to change there, and it was a very much exciting time currently to work in such a big company, to work with all these things. And maybe this morning before you came here you already did a run with Runtastic or something to measure your speed and location. Maybe you're not from Munich and you were lucky to run through the Olympia Park and show it to the other guys, your surroundings, to say, well, see my track here, I was in the Olympia Park. So something like that is what we are trying to do at Continental. Where are the, what we are trying to do, I will just shortly introduce to you. Sorry, my voice today is a bit scratchy, but anyway. So a few years before, Continental thought that all this sensor stuff and all this high-end electronics must be some fun in it. And while the automotive part of Continental was quite used to use these things, Tires was very reluctant to use it. But then they introduced the fleet check tool, which was meant to help all these fleet managers out there who have like 10 or 200 trucks on their yard, to help them understanding how the tire works. Because other than with a car, for a truck, a tire is somehow expensive, and the tire is very, very interesting to the fleet manager, because the tire is the contact to the road, and it's, yeah, as I said, it's expensive, and it helps the driver to be sure in every situation, whether it's wet and slippery, whether there's dust on the road or whatever. The tire is really a very important part of the whole car or the whole vehicle when you're a fleet manager. So we offered them a service where we build a small sensor into the tire. It is really brought into the tire and sending some information about the temperature and the pressure of the tire. And there are some more values added from the canvas of the vehicle, and the data were only collected. That was all they did years before. For the fleet manager, it was quite interesting to see in a dashboard where more or less what is the temperature of all these tires he has in the field or she has in the field, and whether they can see a sudden change in the pressure or something like that. That was all they did. So very much in-situation view of the data. From there we start to build up a whole system, which you can see here. We have this little sensor here which collects all the pressure and temperature data which is in the tire, and this little device sends the data through different telematics at the car. And nowadays we have some own product called the Flexbox. We put it to the vehicle, and this records all this temperature and pressure data. And additionally, now, since almost 2 years, we also collect GPS data, acceleration data, and now we're starting to use also the gyro data. So we have a lot of data, a huge amount of data which we can collect now, and we bring it to it can be brought to a third party backend or to our Conti backend. And this is just to give all the technicians which sitting in the audience here, to bring you a broad picture of the architecture. So we have these boxes here. It can be a steady box. It can also be a box which is not connected to the internet, but only will be read. It collects the data and will be read when it comes back to the yard. And then once it gives all the data via Wi-Fi. These are collected, and then we have a broker system here a message broker, and we collect the data from the message broker. And here you see, I have a pointer. That's cool. Here you can see we build up some system. Actually, when I planned the usual disclaimer, you know, from talks like these, when I planned this talk, I plan to be much further with this whole project than I am currently. But anyway, I give you the impressions we have up to now. So interesting, we have a relational database here, because in the beginning we tried to connect all this stuff to new, in Continental terms, I mean, we are from 1871, so it was quite new, this technology, like Spark and Hadoop and stuff. So we brought this to this new technology. This was a major change in Continental Tire's IT, because Continental Tire IT was completely relied on SAP. So it was an SAP house, and we were the first department to work with these new technologies. But this didn't work from the first day, so we used the traditional database, but also to use the open source database was new to Continental. So that was quite challenging and very interesting to implement all this stuff. Nowadays, the broker collects all these messages from the box and brings it to the to this Hadoop environment, and we're starting to build up huge database, huge amounts of data here, with the target to someday analyze all these data. We are already doing it, but currently there are many manual ways in analyzing all these data. And I will show you some of the examples, what we are as data science department, as data scientists, what we are doing with this data, and what challenges we see there. The first challenge is to provide the data. So just to give you a small glimpse, it's really, we have more data, just to give you an impression. Currently, we are not collecting too much vehicles. It's not that we are bringing our Flexbox system to all the vehicles out there. Someday it hopefully will be that way. Currently, we are more testing tires with it. So it's our R&D department which is working with this box now, just during these days. Yesterday I had a telco on that. Now we are bringing the first box to the automotive department so that they are working with that. And all these data will be collected sort of in my department to be analyzed. And just to give you an impression, only the GPS data, which is this part here, a big load. So, and also these other data like the acceleration data and the pressure and temperature together amount to a huge load, a huge load of data. We have to handle that, and in the first tries, or in the first phase, we tried to do it with Postgres. It worked quite well, but if you try to do an analysis on, let's say, only 10 cars, or even 3 vehicles, then you have to, and you try to do a time series over, let's say, a year or something like that, you won't manage it. There is no way to get all these data into some system if you want to show more than one track for one vehicle. Then you always have a problem. Currently,
what's the problem? Why is that?
Too many data, too much data. So
for which part of the system? So you show the architecture.
In the beginning, it was. In the beginning, we were very plain. We just loaded it to the Postgres and tried to retrieve it from there, and that was virtually not possible.
Postgres databases are the problem.
In the beginning, it was. Now it can handle it. After some we learned something about it. But as I said, in the beginning, it was a problem. Yeah, to retrieve. It wasn't a problem to just make a quick plot the track like you see here, for instance. This we could do also in the beginning. There was no problem to track, let's say, 1 day of data, or even 2 or 3 days of data for one vehicle. No problem. Went very quick. Everything was fine. But the minute the analysts came, the data scientists came and said, we want to do some time series analysis. What's about having 20 vehicles compared over 1 year? That was a problem. Not the time series in the end. This is aggregated. But the way from the database to aggregate it, it took really long. So we had to make some experience and handle it and tried things. And it is better. We're still not there, but it gets better. But first, let me show you something. How our, not only data scientists, how our data consumers work with these data. They want to do things like this here. They have Tableau and they want to show the track to see where the vehicles go. You can see a track over, I think these are 2 or 3 days, and they want to show it in Tableau. You all know that Tableau is a quite nice tool to do some things quickly. And we still use Tableau for it. It's a very good tool when you have, when you only want to plot a track, when you want to do some quality checks. You can load CSV files into there. You can do a direct DB access, but it's no good tool if you want to really do something more, some deeper insights. Then, I mean, it's quick. You can load all the data better than some other tools, but there will be a point when you have to do some data management in it. For instance, when you want to use the GPS data and bring it together with some acceleration data and then maybe also some different special maps or something, then you need to have some know-how in Tableau, and the people who use Tableau mostly don't have that know-how. And in that case, they come to the IT, and IT prefers different tools than Tableau. That's just the point here. So, but it's still used for, especially for those purposes I mentioned here. There are people who are working much more deeper with the data. They use QGIS. QGIS is also very good to access these data and to show things in the files, and it's more used from the GIS guys. They know this tool, they know how to work with this. They have a slightly more technical know-how than the Tableau guys. They know how to, sometimes they even know how to program with Python, so they can use it very good. They can do things like simplify the track. They can do things like measuring distances with using programs for it. They can do things like finding next points of interest and stuff like that. They can all do it in QGIS. And first, in the beginning, they also work with CSV files. That's always possible to do that. Now they are connecting directly to the Postgres database with the PostGIS module. PostGIS is a special module in Postgres which you can use for geographical data. It's very easy to install, very good to use, and it brings you all this stuff that you need when you want to do some geographical analysis, like finding points of interest, finding an optimal route, simplified tracks, things like that. And now we provided a special view layer on the Postgres database where they work with, and this goes quite fast, and they can also load some more than 2 or 3 days of data. It works very well for them. What is interesting here also is they can use shapefiles. Shapefiles is a special format known in the GIS world where they have special other geographical information, maybe special maps or special tracks where they want to compare this stuff to. This is why they want to work with QGIS. We provided a special layer for this one. And we use R Shiny for, let's say, special reports as a layer between data scientists and business. So we do some programming in R, and we use all the fancy geographical knowledge that is in R. There are several libraries you can use there, like the ST package and the lattice map stuff and so. And we program sort of defined reports where we show whatever the engineers, especially in the R&D area, want to see, and provide a ready-to-use R Shiny dashboard to the engineers. This is quite nice, works quite well. Usually there are different ways how we work with it. We either go to the Postgres layer that we also use for the QGIS. Some of the data scientists still get the data, transform it to some special R usage, so they really transform it into R data sets because the data are not needed on the fly, but only in batch processes, and use it then. Sometimes it's a good way to do it like that. And others go here directly to the HDFS and use the data from there, from the Spark and Hadoop environment. So different ways. Currently we're thinking about unifying the access, but as you know, everyone has his own approach, and we were quite liberal on the usage of these data, so different data scientists develop different approaches here to use this. The only thing we unified is the usage of R. We have a defined area for that, and where there's also automatic deployment of the Shiny apps that they are programming. This is the part where we are concentrating on. the right. So where we use PostGIS, it's really, as I said, it's a good software which you can use. We automate the GPS processing with it. The sensors I showed at the beginning, sending their information with 5 hairs, so we have a huge amount of GPS data, and this is not necessary to plot track on the map. So for doing that, we are automizing, we're using PostGIS, and we simplify the tracks, and then we save the simplified tracks, and the users can get access to the simplified tracks. These are much less data, can be loaded very much faster. That's very good. We do different simplifying methods. So here, for instance, we use only each 5th point because we have that much points, or we use an algorithm like the Douglas Polka, which is built in most GIS systems as PostGIS and QGIS. You can find it here, and they are ready to use Python scripts to use it, and then we save the ready simplified tracks to give access there. Here you can see these are the original data, just a section of them, and sometimes we save it as a path, which is a good way to simplify the data, and the user can use only the path data, which is much less on data. But with the paths, you sometimes have problems like you see here. There is a gap in the GPS sensor. Here is the last one, the next one is somewhere here, and the path will go straight to the next point where there was a hole in there. So we are working on algorithms to close those holes so that you can use the path for everything. Yeah, I see my time is really fleeting. Yeah, so I will go. That's what I just said. So in the end, we come up with a system where we collect the GPS data, and first we really store all the data that we have, because we won't lose them. We're thinking of a possibility to store all the data, all the raw data, using Amazon Glacier. You can use it, it's a very cheap possibility, but for the hot stuff, where you really want to do your analysis, your tracking, your tracking stuff like that, we are pre-processing all the data and store them, the simplified tracks, all this stuff we are storing on-premise, where the data scientists can access it directly to do some mapping for it and analysis and stuff like that. We even enrich it with information, for instance, with weather data, and also location data. Here you see we ask for each location that we have, for each latitude, longitude, we ask OpenStreetMap and store these information, like which road he was doing and which type of road, which even city and stuff like that, because these are valuable information for the data scientists to find out whether the road was an autobahn or some street in the city, or even if it was in Germany or somewhere else. So these can be used as features for some analysis. Very big problem, I want to mention it short here, was in the beginning, now we solved it more or less, was to bring together this information, because you don't have a unique key like you know from relational stuff, but we have different sensors for GPS and acceleration, for instance, and we have to bring it together, like the GPS information from here and the acceleration information from there. It's only interesting if you combine it. So we had to use the timestamp for it, and we used R for it. R was the best and fastest possibility to merge information by timestamp, because you never have the same timestamp for two data which belong together. So you always have to do some rolling join, where you find one timestamp, and in the other data table you find the timestamps which are around this one. And we tried several solutions, did also some fancy program in SQL and whatever, and in the end we came up with our solution, which is the best. It is most of the time done in time during the analysis, not beforehand, but it works really pretty well. Some last notes on data accuracy. As you see, sometimes our machines are not really good at pointing out where we are. So we found out that we use the DOP value, which always comes with a good GPS system, and we delete all values above 50. Between 8 and 50 we scrutinize the values, and we keep values up to a DOP value of 2.5. DOP is some sort of dilution of position, is some sort of accuracy measure for latitude and longitude. we use it there. In the beginning, we had our thoughts about speed, whether we calculated with formulas you find in PostGIS or R. We calculated from latitude or longitude in comparison to the speed which is given with the column you find in the GPS data, but it's more or less the same. You see it's more or less only one curve here, but it's an overlay curve of the GPS calculation from latitude and longitude and the other one. Not that good is the distance. As you see here, the blue points, this line, are the real distances from the vehicle, which we read when a mechanic comes to the vehicle and finds it on the tachometer, whatever. And here's the distance derived from our GPS track, and sometimes it deteriorates here. And we are currently working on an interpolation where we correct these values with the real values given here. That's an open topic where we are working on. Same with the acceleration. Sometimes the logger is not built plain into the car, so we find the data are slightly turned, and we just developed a mechanism which finds the derivation of the plane measurement and corrects the values automatically. Just built into the database, so while this pre-processing, we do this here. Yeah, I wanted to show some examples, but I'm through with my time. We have nice Shiny apps where we can do some analysis. If you're interested in that, just come to me, approach me afterwards. We are planning to do some more on these GPS saving of data, key value stores and stuff like that. But if you're interested in that, just never talk to me afterwards. Thank you. If any question, I don't know, is it quite time for questions now?
Thank you. So we have 5 minutes for questions. This is where we basically have to cut you off.
Yeah.
Your questions.
In which format do you save the GPS data in the relational basis database, and what were your lessons learned if you have to handle those huge amounts of data?
Very good question. Currently, we are saving the data in raw format and in PostGIS, in the PostGIS special format, which is some sort of binary format. We're thinking of additionally saving the process data in JSON format, but we're working on that. Yeah. But raw format is quite good. That's our
In use so far?
You mentioned you use Tableau, QGIS, and R-Shiny, right? 3 different tools. So I could imagine 3 different types of, audience or end users in your company.
Yes.
Did you ever consider the fact that there could possibly be a solution that combines all the 3 on the market? If so, would you love it?
We considered the fact, but Continental is very much, as there are many engineers and they have an engineering tradition, they are very used to their own stuff, and it's very hard to bring them to something else. And so it's not really easy to bring people to use something else. And as we are huge enough to support all 3 stacks, we are not really pushing them towards using only one tool. We hope that the tools as itself will convince each user to be the right one. Yeah. So no, basically.
So we have time for one last question. Just raising first.
So I have 2 questions. Is there a problem with the signal sometimes, that there's poor signal for the transmission in some areas? Or
Yeah. Sometimes it's we have a problem, but it evolved. It became better and better with the generations of loggers. In the beginning, it was horrible, and we had to apply filters like Kalman filtering and stuff like that. But now with the latest version, I must say it's really brilliant, the signal. There are sometimes problems with the logger as such that there is no connection. He really logs off sometimes. But the GPS receivers nowadays are really good. I'm really quite convinced of them. Yeah.
Okay, and second question, for which analysis are you using this data? Are you using it to improve your products or to predict failures, or?
Yeah, everything.
Everything.
We try to measure the things that come to the tire as good as possible to improve for instance, to predict the wear of the tire, to predict the endurance of the tire, which things are important to the endurance and the wear. And we also try to deliver services to the fleet managers, as we said in the beginning. For instance, now we're just working on a project which is almost coming to the end, where we can show the driver in which parts of his tracks, and vehicle drivers or lorry drivers are driving the most of the time, they're driving the same tracks, he has to change his driver behavior to spare some 10,000 kilometers of his tire.
Okay.
Things like that.
Okay, thank you.
So thank you very much again, Dubravko Dolic from Continental Tires. Thank you.